So next we have the complex MA5B. So one of the ligands is present 5 times and there is another ligand which is present just once. So there is only going to be one possible pair for this. You can try, you will not be able to make any other possible pairs. In this, the A is trans to A is trans to A, and A is trans to B. So obviously this is optically inactive. Trans pair is getting repeated, the same ligand is trans to each other, so this is optically inactive. So if a question asks you, does the octahedral complex of the type MA5B, or they can give you real ligands, instead of writing MA5B, they can give you there is some metal and NH3 is present 5 times and Cl is present 1 time. Will it show geometrical isomerism or not? So your answer is going to be no. It is not going to show geometrical isomer because there is only one possible pair. You will say that a complex shows a geometrical isomer if there are at least 2 possible pairs. If there is just one possible pair, then no, it will not show geometrical isomerism. Now if we go to our calculations, okay, if they ask you the number of isomers possible, then you will write 1 because there is still one possible pair, but again it is not going to show any geometrical isomer, only there is one pair that is present, and that pair is also optically inactive. So the number of optical isomers is 0, and because the number of optical isomers is 0, the number of enantiomeric pairs is also going to be 0, and the number of stereoisomers is going to be 1. That is 0 optical isomers plus 1 optically inactive isomers. So number of stereoisomers is 1. When I am talking about the one stereoisomer and the one geometrical isomer, I am counting just that possible pair. But if it's just ask you in word whether it is going to show stereoisomerism or whether this complex is going to show you geometrical isomer, your answer is going to be no, it is not going to show any geometrical isomer. No, it is not going to show any stereoisomer. Similarly, we have this next complex MA6. For MA6, this is the only possible pair. In this, A is trans to A is trans to A is trans to A, because there is no other ligand present. So we have only one possible pair. So this complex is also not going to show you any geometrical isomerism. But the number of geometrical isomer is going to be 1. The number of optical isomers is 0 because that is optically inactive, because A is trans to A is trans to A, again A is trans to A. Number of enantiomeric pairs is 0. Therefore, the number of stereoisomers is equal to 0, which is the number of optical isomers plus the number of geometrical isomers. So, it gives us equal to 1. So, these are all of the examples that I tried to do for your unidentate ligands, that is, or monodentate ligands, that is ligands which have just one donor atoms.